This podcast is from the RAND Corporation, a nonprofit institution that helps improve policy and decision-making through research and analysis. Visit www.rand.org to learn more about us and to explore RAND's free online library of more than 10,000 policy reports and commentaries. Ladies and gentlemen, the President and Chief Executive Officer of the RAND Corporation, Michael Rich.
Welcome. This is the 11th Haskins Lecture at RAND. It's a lecture on science policy. But this is an important year for RAND because in less than 4 months, we're going to mark the 70th anniversary of the independent RAND Corporation. RAND was established by an Army general shortly after World War II. It was General Hap Arnold, and he created Project RAND. The name is simply a contraction of the term research and development, R&D. He wanted scientists who weren't part of the government establishment, who weren't part of any commercial enterprise, to be able to continue their scientific contributions to national security, free from any inappropriate influence or bias. Our mission is the same as it was in those years. It's to help improve policy and decision-making through research and analysis, totally independent of any political or commercial interests. Now, RAND's first report was entitled A Preliminary Design of an Experimental World-Circling Spaceship. It was published more than a decade before the launch of Sputnik. And many histories of the American space program point to the publication of that report as the beginning of space exploration in the United States. And today, our multidisciplinary research teams are analyzing how science and technology are shaping the 21st century. Big data, artificial intelligence, driverless cars, cybersecurity, stem cell research. Those are just a few of the many streams of research and analysis underway here. Scientific and technological innovation is critical for the welfare of society, and RAND's, I think, increasingly rare brand of nonpartisan, evidence-based research is, in my judgment, more and more important, and I hope you agree with that. So it's now my pleasure to introduce our speaker, Dr. Mae Jemison. Dr. Jemison made history 25 years ago now when she went into space as a crew member aboard the Space Shuttle Endeavour, becoming the first woman of color to travel in space. But before becoming a NASA astronaut, she was the Peace Corps medical officer for Sierra Leone and Liberia and a general practice physician here in Los Angeles. She also taught environmental studies at Dartmouth, started an international science camp for teenagers. And I know it sounds like I'm introducing a panel, but trust me, these are all one person's accomplishments, and there is more. Dr. Jemison's many honors include induction into the National Women's Hall of Fame, the National Medical Association Hall of Fame, and the International Space Hall of Fame. And she holds at least 2 other distinctions. She was the first real astronaut to appear on Star Trek, and the first to have a figurine modeled on her in the new Lego Women of NASA kit. Today, Dr. Jemison leads the 100-Year Starship initiative, and that was launched with a seed grant from DARPA, an organization, an agency very familiar to RAND. And its goal is to assure that humans have the capabilities to travel beyond our solar system to another star within the next 100 years. Quite a vision. Now, I've wanted to meet Dr. Jemison for a long time because 3 years ago, we included Dr. Jemison in the RAND wall calendar of inspirational quotes. And that's a calendar that we've been producing every year since 1959. And her quote was about getting young people to pursue science. And in it, she observed how humans the world over, throughout time, have gazed up at the stars and wondered what they are. And she called it one of the unifying experiences that all humans, no matter where they are, no matter who they are, all humans have. And it takes, I think, a special person to remind us of that fact and to do it in such a memorable way.
The following are highlights of the 2018 Haskins Lecture, delivered by astronaut, physician, engineer, professor, entrepreneur, and visionary, Dr. Mae Jemison.
The way we move ahead is by doing bold things. Let me give you a little bit of my background. I grew up during a time where our potential seemed limitless. I grew up in the 1960s. And I remember the 1960s very fondly. And like a lot of people, when I think of the 60s, I think of it as a time where we were changing everything every day. We were breaking new land records, in terms of speed, right? We were setting new records in terms of our ability to find new subatomic particles. All kinds of things were happening. And it wasn't just about the sciences, it was also in society. It was really about creativity. When you think about it, in the 60s, there was decolonialization, there was a women's movement. We were changing how we were looking at religion and life and culture and art. Now, I wasn't old enough to be a hippie. I always resented that I wasn't. But when I look back, that's what it's about. Truthfully, I played with Barbie dolls. I had a chemistry set. As you can imagine, I was an original series Star Trek fan, and I pondered the concepts of infinity and the Big Bang. I lived on the south side of Chicago. I remember the civil rights movement. I remember the riots that happened in Chicago in 1968 following Martin Luther King's assassination and the Democratic National Convention that had been held in Chicago. I remember being afraid for my father who had gone to work that day. But like every kid, I had this incredible thirst for the knowing about what was going on in the world around me. I wanted to do lots of different things. But one of the things that I wanted to do was to go into space. This is my proof of picture. I got to do it. Got to show a couple of those. But the reason why I'm showing them to you is because it was something that, again, it starts to unify us. And in fact, a West African proverb says, no one shows a child the sky. Around us, around the world, every group of people, every society have had people who observed the stars and paid attention to them. When we think about this, no one shows a child the sky. I do know that the preliminary design of an experimental world circling spacecraft came out of Rand in May 1946. Was it the beginning of space exploration? I'm going to have to say no. The reason why? Because space exploration really began thousands of generations ago. When one of my ancestors looked up at the stars, we were looking and said, that spot of light right there, 10 years ago, it was right there. Can you imagine the observational capacity that it was required to do that? That's what we're building on now. Space has been part of everything that we've done for generations. We learned how, it was from our first technologies, right? We learned how to plant based on lunar cycles, right? Observing the moon, when certain stars rise in the sky. That's how we knew about seasons. We navigated from the stars. It's been part of us. So space has been there. Yet, so many times when we think about space exploration these days, people talk about it leaves folks out. We don't think about it as being part of our world. And in fact, Julius Nyerere said, who's one of my favorite people, he said, when they were trying to reach the moon, we were trying to reach the village. So the idea was that some kind of way space exploration doesn't impact all of us, but it does. Think about it. We're able to reach the village in many cases right now because of space exploration. We're able to communicate with each other. If we just think through what's actually been happening over the years, we have been able to do lots of different things. We've been able to make lots of things happen. Whether we talk about health, right, from magnetic resonance imaging machines that use the same algorithms that are used to help turn digital signals from a planet like Venus into images. Those algorithms are used to turn digital signals from your body being put in a magnetic field into images that a physician can read. Everybody has their smartphone. We walk around with our smartphone. Does anybody here have a smartphone? Yeah. You have a space receiver in your pocket or your hand. Fundamentally changed our world. I live in Houston, Texas. We like weather satellites, right? Earth observations, agriculture, so many things are changed fundamentally as a result of this. Centuries passed after someone looked up at the stars and realized that they were moving. And 1946, Rand wrote the paper. 1957, the Soviets launched artificial satellite Sputnik. In 1961, President John F. Kennedy began a dramatic expansion of the U.S. space program by committing our country to landing a person on the moon by the end of the decade. That was really the pursuit of the extraordinary. That's where we pushed really hard. And then we eventually got the Gemini, the Mercury program, Gemini, Apollo, the first spacecraft to orbit another world, the Space Shuttle, the International Space Station. We got Voyager, right? We got Viking going around other planets. So much of this we take for granted. But we're at a point now in space exploration where people are asking the question, what happened to NASA, right? You've heard people say, well, is NASA still flying? How do we get people to do, why isn't NASA doing anything in space? And that's because we sort of pulled back. At some point in time, now NASA is still doing incredible work in many ways. We're still flying in space. There's people who are like 6 astronauts are on the International Space Station right now. There is a lot of work going on, some incredible, we're finding exoplanets and all kinds of things. But why aren't we doing more? Why aren't we pushing harder? In space exploration, what would pursuit of the extraordinary be? Mars, right? The question I ask is Mars audacious enough? Since the majority of people on this planet have been born, we've had something on Mars, right? We know Mars' address. We have rovers crawling around on it, all kinds of things. Mars, I will confess, I would go to Mars in a heartbeat. But Mars isn't the kind of challenge that we don't know how to do. We can plot out a technology roadmap for Mars. Really easily. I sit on some exploration committees that do that. But the question becomes, why don't we try something we don't know how to do? When we had the challenge of going to the moon, we didn't know very much about how to get to the moon, what was there. And it really forced us to do things differently. So the challenge I'm taking up, let's try something really difficult. Let's try Interstellar. Okay, we're at Interstellar, going beyond our solar system to another star. And you heard 100-Year Starship was seed funded by DARPA to ensure that we have the capabilities for human travel beyond our solar system to another star in 100 years. Not a launch date, but the capabilities. And that's where the important part comes in. How do we create the capabilities? Why is this difficult? Because it's the extreme nature of the hurdles of Interstellar that make us reevaluate what we think we know. We can't do it using today's technology. It demands that we have radical leaps. Let me show you what I'm talking about. This is the way space exploration looks now. If you look closely, you can see me on the middeck. That's actually my shuttle. But the thing is, even though the shuttle isn't flying, all that, that's a chemical propulsion, all the smoke and fumes and all that kind of stuff. We can't get to another star using that, right? It's going to be something as different as this. Maybe not this clearly, but something that might hold the Empire State Building inside of it. It's going to be very different. This is the way space exploration looks now. If you did not know that I flew on the shuttle, you couldn't tell that that wasn't the space station unless you're a really big science geek. Or you couldn't even tell that it's not even that much different than Skylab when I was in high school. But Interstellar won't be like that. It will be as different from low Earth orbit as that is to the bridge of the Enterprise. And if you have a picture with Worf, you show it. So that's my final proof of picture. We're not going to find Worf. That's not it, but it will be that fundamentally different. Why is it going to be that different? Let's look at the scale of travel from another star. Think of Los Angeles and New York City. Los Angeles is Earth. New York is Alpha Centauri, which is our closest neighboring star. It's 25 trillion miles away, 4.2 light years, the distance light travels in 4.2 years. To put that in perspective, light travels from the sun to the Earth in 8 minutes, and that's 93 million miles. It's a long way away. Voyager, which has just left our solar system, has been traveling at over 35,000 miles per hour on average. And if you look at this trip, Voyager would have only traveled 1 mile in that time since 1977 on the journey. It would take Voyager over 50,000 years to get to Alpha Centauri. So clearly we have to do something different because we weren't cave painting well back then. We have to do something much faster. So it fundamentally changes the way we do things. Understand what the Interstellar Journey also does. It's the distance, right? So we have to get over these tremendous distances. It's the time. Even if we're able to go some percent of light speed, 10% of light speed, we're still talking about 100 years or 50 years. So we have a different time scale to work with. It's the autonomy. If you get to going that fast, you're not going to be able to slow down and get groceries. You're going to have to be able to carry everything with you. So it forces us to look at things differently. And then finally, 90% of it's called dark. Now, I know I'm going to take some license with this, but basically dark matter is something we're trying to figure out what it is. Dark energy, we don't know what it is, but it's a fudge factor. We know it's something has to be out there to make our equations work. Right? So this is what we're dealing with. But isn't that what we're doing when we try to prepare for the future? Right? When we look forward, we have to deal with things that are in the dark, time and distance and all these things that are different. And some of the ways you can look at requirements for success for going into the dark are these things that we have to do. We have to be open. We have to use existing knowledge and capabilities in new ways. We have to be flexible. We have to be self-sufficient. We have to have reality testing. We have to have an internal compass that's not determined by competition with someone else, right? We have to do all of those things. We have to have systems based on radically unexpected partnerships. Those are the pieces that we're looking for when we talk about how do we get better policies? How do we get the world that we want to live in? And I'm just going to put down some of the sampling of the areas in which radical leaps are important. Energy, we have to control, store, and generate tremendous amounts of energy. We can't do it with chemical propulsion. There is not enough chemical propulsion in the entire solar system to get to another star in a reasonable period of time, which that means we're going to have to do fission, breaking atoms apart, fusion, what powers the sun, where atoms are pushed together, or we're going to have to do antimatter. We don't know how to do all those really well and control and store them. But imagine if we were able to just go a little bit along that path, what it would mean to life here on Earth right now, to what we do. We have a range of things. If we could look at sustainability for self-correcting equipment and machines, human health and behavior, our microbiomes, all of those things make a difference. We talked about investing for things. If we invest now for a short term, this requires that we invest for a long term. Wouldn't that make a difference for us here on Earth if we figured out how we do well that way? So the challenge of human interstellar flight really mirrors the challenges that we face in the world today. Eugene Cernan said, "We went to explore the moon, and in fact, we discovered the Earth." And the question I would ask is, what will we discover from another star? Is this too big? Is it too bold? I want lots of people to be involved, from the layperson to the person who's a deep subject matter expert in space, from the person who tells a story really well and gives us incredible film. My dance instructor from college, who is an anthropologist, she wants to be involved because she says she can tell some of these stories through dance. I want so many people to be involved because some kind of way we have to connect as humans. And if by chance doing the audacious big things, funding things that don't have immediate need, if it seems crazy, I want to share one thing with you. Cynthia Hamel said, "When in doubt, make a fool of yourself." There's a microscopically thin line between being brilliantly creative and acting like the most gigantic idiot on earth. So what the hell? Leap. Thank you very much.
This presentation is provided as a public service by the RAND Corporation. To learn how you can attend programs at RAND, Visit us online at www.rand.org/events.